Good afternoon. This is David Robison with Design Master. We're going to be doing our training today on recurring panel templates in Design Master Electrical. The clock on this computer is actually a little bit slow, and it's 1 o'clock now, so we're going to go ahead and get started. You can ask questions over your line if you want to, or you can also use the chat box in Blizz, press the two little chat bubbles, and then you can type questions if you have any there. So I'm going to go ahead and get started and start walking through recurring panels. And if you have questions, go ahead and type them in or ask them, and we can address them as we're going through here. So today we are looking at recurring panels. These are panels that you can use multiple times in a project. The idea is that you have some panel that, for whatever reason, is duplicated in a project. Common use for this is like an apartment. In an apartment building, you might have separate panels for each apartment, and you'll have multiple apartments that look the same. And so you'll want to create one template of the panel that has the apartment all nicely laid out, and then you just want to kind of duplicate that in the building for each of those apartments. And then when any of the apartments change, you want those changes propagated to all of the instances of those apartments that are in the project. So that's the idea behind the recurring panel, that you have a single master panel that is going to be used multiple times in a project. So on the ribbon, we have all our distribution equipment types: panels, switchboards, transformers, and then at the bottom here we have the recurring panel section. We'll first look at recurring panel templates. So the template is the reminding me that I have an update to the software. We'll ignore that. Recurring panel templates. These are the main template that you use to define like an apartment type that's going to be used multiple times. And so this is where you define what that panel is going to look like. So I'll call this, for example, apartment A. For example, if we got multiple apartment types. So this is apartment type A. If we go back and look at the panel dialog box, so this is a standard panel, you'll see that this looks very, very similar to recurring panels. There's going to be two changes, two things that are missing: the feeder length and the actual fault. So a panel has a feeder length and has a fault at it. A recurring panel template doesn't, because the length depends on where the actual panel is inserted, and it's going to be inserted in multiple spots, so they don't have a length and they don't have a corresponding fault or voltage drop to them. So the fault analysis is a little bit smaller. Everything else here is exactly the same as a panel. So they're supposed to look exactly like a panel, but just be able to be used multiple times. And then also, there's one other thing. If you go into schedule settings for recurring panel templates, they are not shown in the fault schedule, on the voltage drop schedule, or in the one-line diagram. Because they're a template and they don't actually exist in the project anywhere, it doesn't make sense to include them in any of those schedules. So you don't have the option to turn it on and off. Instead, when we look at instances, you will be able to create a recurring panel instance and then display those in those schedules if you need to show values for them. So we have apartment A, which we will leave as it is here. I'm also going to create an apartment B, so we can just see what happens when we have two different templates. So we'll create apartment type B. So now we have two different recurring panel templates for two different types of apartments in a building that we're looking at. For example, say we have a 2-bedroom and a 3-bedroom apartment, or something of that nature. So that creates the panels, and you can set all the same settings that you normally do for panels. And then you can circuit things to it. So if we go to circuiting, you'll see that the recurring panel templates are listed here as panels, as distribution equipment to select. And so you can select the piece of equipment, the recurring panel template, and then connect things to it as you normally would. You can either use fixed loads and just specify what the loads are on each circuit, or you can actually connect the devices that you've inserted on the panel, on the plan. So for example, say if we have something in here, say this is our apartment, and so we want to put some pieces of equipment in here. Say we've got a couple of receptacles. We can put those, and then we can actually circuit these up to the template. So we can circuit those devices. So you can lay out kind of a typical plan for each template. So you'd have your typical apartment A, lay out some light fixtures, or some receptacles, and actually circuit things, draw home runs, use all of the Design Master drafting tools to do a nice typical layout that you're going to use multiple times in the project. So you can either lay them out, again, on the plan, or you can use fixed loads, depending on which is easier for what you're trying to do. And so that's how you actually get loads on the template. And then you can insert instances which correspond to actual locations of those apartment types in the project. So if we go to the recurring panel template, the pull down here, we have the create instance command. And here is where we actually create a recurring panel instance based upon that template. So we specify which template it's based upon. Is this an apartment A or apartment B? And we give it a call out. So let's take apartment A. Say this is apartment 101, so we'll call it 101 so that we have some corresponding name for it. You can create it on the drawing or in the database. If you create it in the database, it'll exist. You can connect it to other pieces of distribution equipment, get it in your model, but you don't actually have to physically locate it if you don't want to do that. If you want to, you can also place it on the drawing, and then it'll calculate feature lengths for you if you ask it to. So we can create it on the drawing here. So it puts in a panel with the label, and so then we have a specific instance of that template. And we could also do apartment 102 the same way. Create this on the drawing. So this would correspond to, say, there's two apartments next to each other with the same layout. So these are going to have both of these, in this case, just these three receptacles are going to exist on both of these panels. And so then when we connect everything up, it'll see that it has those three receptacles those loads being carried up to the main panel that's feeding them. So to connect these instances to other panels in the project, you use the standard connect distribution equipment command. So we treat them like standard panels. So you've got your regular panels up here, and then you have all your instances down below. So we can take instance 101 and connect it to one of these panels that we already have in the project. I'll put it on L3 here. This happens to be a 3-pole panel. And so we can connect 101 to L3, and I'll connect 102 to L3 also. So if you have a lot of recurring panel instances, and you typically do, it's a little cumbersome at times to go through this dialog, but that's just the dialog that we do have for connecting equipment together. So that's how you make your connections, same as any other panel in your project. And you can also connect recurring panel instances to each other or other panels to them. So we originally put the whole thing together and tried to make the recurring panel instances match the template as close as possible, but there are cases where you have these instances that are not quite the same as each other, but pretty close. And one of the places where they can be a little bit different is when you actually have downstream instances connected together, if you kind of daisy chain multiple together. So we could take this 102 and connect it to the 101, though actually we need a lug connection. So if I go back and I run the edit command, I'll pull up the instance. I don't actually want to edit that. I want to change the template. If we go back to this template, I'm going to change the lugs to a double lug so we can just daisy chain on the top lug there. And so now we can connect 102 rather than having it feed from L3, we can have it be fed from 101 on the top lug connection there. And so now 101 is going to have the load of obviously the 101 instance and the 102 instance, and then L3 will have the loads for both of them. Let's see where I want to go next on that. Let's look at some of the other settings you can set for your instances. We have a query or edit multiple, so you can change multiple at a time, or you can edit just one instance at a time. I'll take this 101. We have the option for a feeder length. So if you place them on the drawing, we calculate the feeder length to that recurring panel instance based upon the location of it and what it's connected to. You can also override it. The panels have an AIC rating assigned to them, but you can override that as well if you have an instance that has a higher fault than some of the other instances. You can specify a different AIC rating. You can change the description that's going to show up in the upstream panel. Normally it'll just be the description of that panel, but you can change that. And then they all have a schedule block associated with them. And if you need to, we'll take a look at the schedules, but there might be times when you might need to choose a different schedule block depending on where it is in the system is to get the right footer on there. Then you have the option to show the instance on the feeder schedule, in the fault schedule, voltage drop schedule, arc flash, and one-line diagram. And these 5 schedules places all kind of work the same, so we'll talk about them together. The idea here is that, like I was saying, you can't show a template on those schedules because the template doesn't really exist in the model anywhere. It's just a placeholder that you're going to insert as an instance. And then the instances you place on in your project, and so you've got them, and typically you're going to have a lot of them. So you don't necessarily on your fault schedule want to show all of the instances because you've got 100 apartments, and you don't want to show the fault at all of them because it's all going to basically look the same. So you can if you want to. You could turn it on for all of them. What a lot of people do is they turn it on for a representative one, just a typical. So they choose one. They say, okay, this guy is maybe the farthest one, so we know it's going to have actually you want for fault, this is the closest one, so it's going to have the highest fault. So we want to show this one in the fault schedule. So you could turn this one on to show in the fault schedule, and it's going to default to include its name. You could also override the description and say, this is typical apartment A. So that in the fault schedule, it has a different name saying that this is just kind of the representative typical value, depending on what your plan reviewer is wanting and how you're trying to document what's happening in your project. So you've got that option for the feeder, fault, voltage drop, arc flash, and schedules, and then also in the one-line diagram. So you can show them all in the one-line diagram or just show specific ones if you only just want to show a representative one within like typical labels saying that that's what that's representing. So we'll go ahead and leave that one on for the fault schedule. So if we go take a look at our fault schedule and we run our update on it, we'll actually add that apartment as a typical, and it's overrunning our column there, so we want to make that column a little wider. We'll do that so we can actually read what's there. So there we've got that typical apartment being shown, but just that one and not the other, the 102 that I inserted. If we say take this voltage drop schedule and update it, I didn't ask anything to be included there, so you're not going to see anything added to that voltage drop schedule at this time. So we update the voltage drop schedule. It ends up looking exactly the same, other than slightly changed voltage drops because we have different loads now. But we're not seeing additional pieces of devices because we have not added them. Going back to the query and edit, we have the option to do a list of all of your instances in the project. And so if you have them in the list, you can put on each individual instance a couple notes. So you have that option for scheduling if you want to list all the instances. Specify the elevation. So if they're in a different spot on the floor, you can locate that for each instance. And then each instance also has the option for specific clearance values for the box we draw outside of it. Finally, we have the feeder specification. So by default, the feeder for the instance is going to match what the feeder is set in the template. But there are times when you are going to have an instance that needs to have a feeder that's upsized. And so the way you do that is you come here, you get the instance, and you say it has a custom feeder specification. So it's not using what's in the template. It has something a little bit different. And then you have all of our standard feeder sizing options. You can override the upstream breaker size, or just override the conductor amps, the wire size, if you need to do that for voltage drop. And also the ability to adjust the neutral or ground and the conduit size. So all of our standard feeder specifications available for each instance. And if you don't make any changes there, it's going to pull the values from the template otherwise. Take a moment and take a drink of water here. Now let's take a look at the panel schedules, because those are a place where you need to, you sometimes want to make some changes to how the schedule ends up looking. So if I insert my panel schedule, I already have my L3 here. And so if I update that, we have the panel 101 being shown there with that bit of receptacle load on it. You can then insert a schedule, and you have a couple options for the templates, for the schedules that you show. You can show the recurring panel template schedule, which is just kind of a very generic schedule. It's not going to have any feeder length options, and the fed from obviously is not going to be set because it's just the template. So you can use that if you want to say, okay, here's just the generic, apartment A template. So we could put that in. And it's not a terribly interesting schedule, but this is what it's going to end up looking like. You also have the option to insert the instances as a schedule. So we could put in 101 as a schedule, and then also 102 as a schedule. And here, the difference that you'll see is that 101 and 102 are in general going to look exactly the same, except they've got different locations they're being fed from, because obviously they're connected to different things. And then 101 actually has the lug load from, so it has the load from panel 102 being transferred to it. So it has a higher load on it than 102 has. So if you have these multiple instances connected to each other, they're based on the same template. They have the same set of things connected to them, except they can have additional pieces of equipment connected downstream, so you can get different loads on them. And so you can put in different schedules for them. And this means then, if you're using some of the multifamily dwelling calculations, that the instance at the end of the run is going to be a single dwelling unit and is going to have one calculation that you can use. But if you're using the multifamily, if you have, say, 3 or 4 connected together, you can actually use the optional multifamily dwelling calculation and have a different footer for it. So just to show you how that would actually look, let's go ahead and put in one more one more instance here. Call this 103. Create it on the drawing, put it over by my other ones. And I'm going to connect 103 to 102. So now I've got 101, 102, 103 all connected to each other. And we are going to change the template here. Go into the feeder and service calculations. And for our load calculation, rather than using a default our general calculation, I'm going to change it so that we are using a multifamily dwelling unit calculation. So now the whole project is being done as a multifamily dwelling unit. And so we can specify how many units each of these instances that are inserted based on this template are going to represent. So we'll set this to 1. So each instance is going to be a single unit. And just for completeness, we'll go ahead and put 1,000 square feet, so we have a little bit more load on there. So now each apartment A is a single dwelling unit, 1,000 square feet. So I'll put in one more panel schedule here. We'll put in 103. And then I'm going to go ahead and update all of these just so we can see what the loads we're getting. So 103 is a single dwelling unit, and it doesn't have anything else connected to it. 102 is 2 dwelling units, so it has 102 and 103 connected to it, and then 101 has all 3 of them connected. So at 101, so for 103, we're calculating it as a single dwelling unit because there's just one. 102 and 101, we're actually doing a different calculation because there's multiple dwelling units. So in that case, you need to use a different panel schedule to show that properly. And the way to do that is to change it here and use a different schedule block. So rather than using our standard schedule block, I can change it to use the multifamily dwelling schedule block instead. Update this panel schedule, and that'll pull in the new. Let me check that again because it didn't update. So 101, custom schedule. I'm going to go ahead and erase and reinsert it. There we go. It wasn't updating properly when I did the update, but there it is with the different footer happening there. And you'll see that, so it's got the 3 dwelling units because it has 101, 102, 103, and then the load based upon that. So this way you can get your feeder size correct for the 103 panel, which has a single dwelling unit and has one calculation method required by the NEC, and then that's going to be different from the calculation method required for 101, even though both of those panels are based upon the same template. So we do our best, and we try and keep the templates as the same as possible so that they're actually truly the same thing, and if they're different, then make them different templates. But there are a couple of little places where the templates where the instances do vary, mostly based upon if there's anything else connected to it and then how long those feeders are. And so some of the feeder sizes update as well. And that covers all the different options that we have here for our instances. The other commands we have available for recurring panels, we have the ability to insert it on the drawing. So when we create it, take apartment B, I'll create a 201. We can choose to create it in the database. And so now we have it in the database. We can connect it to other pieces of equipment, but it's not actually on the drawing. So if you just want to create all your panels ahead of time, you don't have a layout necessarily from the architect, you can just go ahead and create them all in the database, and then later you can use the insert on this drawing command to locate that recurring panel instance somewhere on the drawing. So I could take that 201 and place it here. So now it's actually on the drawing. And we have the corresponding command remove from this drawing. We can run the same command, that command, and it's basically the reverse. It takes that panel, removes it from the drawing. It's still in the database. It didn't totally delete it, but it's no longer being shown on the drawing, so it's just in the database at this point. And finally, we have the option to delete it from the database. So there we can take something that is just in the database and delete it from there. So we could get rid of this one that way. If it's on the drawing, you can actually just erase it here, and that will remove it completely from the drawing. final command is the convert panel to recurring panel template. That's where you start working on a project, you have a panel, and then you realize, oh, I did this whole panel, and this panel is actually going to be used multiple times in the project. What you can do is you can take the panel and convert it to a template and then insert those instances. So if you weren't sure or the project changed and you need to convert it to a template, you have the option with the convert panel to recurring panel template. We do not have the corresponding reverse command, converts templates to a panel. That's because there's a lot of complications in terms of what happens to all the instances and everything like that. So we just left it that if it's a template, it's always going to be a template. And so if you need to change it from a template to a panel, basically you end up leaving it as a template and insert a single instance of it, and that's the same thing as a single panel. It's maybe slightly more complicated than if it's just a panel, but converting it back the other way gets messy, and so that's what we chose to not implement that as a feature, because it could potentially cause more problems than it solves. So you can go from a panel to a template and then insert multiple instances. If you need to go the other way, just insert one instance, and that's all the more you need to do about that. These panels on the drawing can have home runs drawn from them. So if we go to our circuiting, we can do our draw home run command. So you can actually document where these are being fed from a little more easily. Can't remember if we implemented that for standard panels or not. I know for the recurring panel instances we needed to do it because a lot of people wanted to be able to know where they're being fed from. I'm just going to check here. Yeah, we did actually implement that for all panels. So you can actually do that for any panel. Sometimes I need to check a feature to see if it still exists or not, or if we implemented it. So you can do that for any panel. That feature was added for the instances because there's a lot of time with, you got these instances, you want to know what they're connected to because there tend to be a lot of them and you need to document those a little differently sometimes from a standard panel. So you do have that option for seeing where they are connected and putting in those home runs. And I think that covers it for recurring panel templates and instances. So does anyone have any questions on those? Two of you who have joined me for this pre-Christmas training. The question is, we go back to where you pulled the home runs. I don't, so there's a question, I don't see where 101 comes from, just the feeder. So 101 has the home run here, showing that it's coming from L3. 102, it looks like a bug, because and I'm guessing it's related to the fact that it's coming from the top lugs. So it's not actually getting that call out in there properly. So I've actually notated that as a bug. No one else has pointed that out. Apparently no one's using that feature because they should have mentioned that. So that is something I'm going to look at when we're done here and see why that's not showing the right label. Because it should have the 101 top lugs or something. I'm assuming 103 will do the same, yeah. Thank you for attending the training. And we will see you back next month for more training on the electrical software.